All right, we just have one last topic in our inverse section, and this is a way that we can determine whether two functions are inverses. And essentially, what we want to remember or know is that if we have the composition of inverse functions, f of g or g of f, that in both situations it's going to simplify down to x if they are inverses. And just a reminder what this, composition notation like g of f of x means g composed of or g of f of x. So we would be plugging f of x into the g function. And so what these rules say here is that if you set up a composition f of g, g of f, and it simplifies both directions, f of g and g of f, you simplify those compositions down. If your end result is x and just x, then that means the two functions are inverses. So in this situation, we have two functions, 2x plus 6 for f of x, and x minus 6 all divided by 2 for g of x. And if we wanted to determine if these were inverses, well, I would need to perform the composition in each direction. So I'm going to look at these like this. So the first thing we'll do is we'll do f of g. F of g of x. And f of g of x means I'm putting g into f for that x value. So I have 2, g of x is x minus 6 over 2. That's what went into my x plus 6. And so looking at this, you'll notice the x's, the 2's will cancel, which leaves me with x minus 6 plus 6. The 6's cancel and we just get x. So the other direction must work as well. So g of f of x means that I'm going to take my f function and plug it into g for that x value. So g of f of x, I end up with 2x plus 6 for my x minus a 6 all divided by 2. And simplifying this, I end up with 2x over 2 because those 6's cancel, and it simplifies to x. So therefore, they are inverse functions. All right? And since they're inverses, and since when you plug the value in, you get out x, if we were asked to find f of g of 4, it would just equal 4. So if we move to our next example here, again, if we wanted to determine if they were inverses, we would perform that composition in both directions. So f of g gives us 3 over 2, and I'm plugging in for x, negative 3 over 2x. And when I look at simplifying this, times 2 divided by 2 cancels. I have 3 over negative 3 over x. Copy, change, flip, that's 3 times x over negative 3, which simplifies to negative x. And right there, as soon as we don't get x, we know that they're not inverses. Negative x is not the same as x. And even if we do it in the other direction, if we do g of f, we're still going to get that it simplifies to negative x. So they're not inverses. And the last thing we want to talk about here is just evaluating an inverse for some number. So f inverse of f of negative 13. So here we're given a function, f of x equals x plus 3 divided by 5. And we're asked to find the inverse function. And once we have the inverse, then we're going to perform the composition f inverse of f and evaluate it at negative 13. So start with y equals x plus 3 divided by 5. Then we'll switch our x and y values. X equals y plus 3 over 5. And I'll multiply on both sides by 5 to work to isolate that y, and then I will subtract 3 on both sides to get rid of that plus 3 on the right. So I end up with f inverse of x equals 5x minus 3. And so in this case, we're asked to find f inverse of f of x. F inverse of f of negative 13. Right, so we can plug negative 13 into our original function. F of negative 13 is negative 13 plus 3, which is negative 10 divided by 5. We get negative 2. So f inverse of negative 2 is what we need to find here. 5 times negative 2 is negative 10. Take away 3, we get out negative 13. And that should make sense that we get negative 13 because f and f inverse are inverses.